Hello student, today we are going to discuss about CBSE sample paper solution class 12 physics question we are going to see. Okay, it is for term 2 exam 3 mark question we are going to discuss. Okay, if you want 2 marks and case study question means you can go and see in my playlist. Okay, now I am going to solve with the problem from the ray optics, question number 10. This is the question we are going to discuss. Okay, first we will see what is given in the question. The lens they placed in a air. Okay, the refractive index of lens is 1.5 and the focal length is 20 centimeter. Okay, now what will be the new focal length when the placed is the refractive index of 1.25? okay, liquid, the same lens they inserted inside the liquid. Now what is the focal length? Okay, this is a question we are going to discuss. First we will see the situation. Okay, we have the lens in a air medium, okay, which is going to called as a 20 centimeter as a focal length. The refractive index of A to G, which is going to called as a 1.5. okay, now they kept us some liquid. They don't know what is a liquid. Okay, they are given the liquid refractive index. Okay, glass refractive index 1.5, liquid refractive index 1.25. Okay, now what is a new focal length is a question mark. Okay, this is a focal length in air. Okay, now actually we have to use a lens maker formula. 1 by f is equal to refractive index of first medium to the second medium minus 1 by r1 minus 1 by r2. okay, this is a refractive lens maker formula for commonly you can use for the lens. Okay, now first situation, 1 divided by focal length in air 20 centimeter, that's going to be refractive index of A to G minus 1 divided by R1 minus 1 divided by R2. This is called equation 1. Same lens when they are inserting inside the liquid, no, refractive index is not going to change. Sorry, radius of curvature not going to change. Only refractive index will be changing. Okay, 1 divided by focal length in liquid, we don't know. So refractive index of liquid to glass. Now the light is traveling from liquid to glass minus 1 divided by R1 minus 1 divided by R2. Okay, is equal to second equation. This is 20. This is 1.5. Okay, this we don't know. This we have to find. Okay, now first we will find the refractive index of when the light is traveling from liquid to the glass. This only we have to find first. Okay, refractive index of A to G 1.5, refractive index of A to liquid which is given 1.25. okay, now liquid to glass, this we have to find because when it is inserted inside the liquid, the light is traveling from liquid to the glass. Okay, so I'll use the refractive index in a multiple medium. Refractive index of 1 to 2, 2 to 3 and 3 to 1 is equal to 1. Okay, so A to G, A to liquid, liquid to G, okay, G to A is equal to 1. This only we want. Remaining 2 you can bring as a denominator. Refractive index of liquid to glass is equal to 1 divided by refractive index of A to liquid 1.25 into G to air. Okay, we got glass to air, but we have air to glass. Okay, opposite only we have. Okay, that also we should find. I used reversibility principle to find. So refractive index of liquid to glass is equal to 1 divided by refractive index of air to liquid into this, no, 1 divided by A to G. Why sir you are writing like this? Because A to G, G to A is equal to 1. This is called reversibility principle. Okay, if you want A to G is equal to 1 divided by G to A. Okay, so opposite. So denominator directly will come into the numerator. Okay, the refractive index of liquid to glass is equal to refractive index of air to glass divided by refractive index of air to liquid. Direct also you can take it this formula. Okay, what is this 1.5? What is this 1.2? Okay, if you are substituting that ratio, you will get the answer 1.5 divided by 1.2. So you can take it as a round number. So just numerator 10, denominator 10, you can multiple 15 divided by 12. Now the refractive index of liquid to glass, okay, liquid to glass is equal to 15 divided by 12, 1. So 3 will come here, okay, 0.0, 24 will be 2 times, okay, again 6 will come, 0, 60 will come as a 5 times. So 1.25 as a refractive index. Sorry, this value is a 1.25. okay, so 1.25 you can multiple numerator 100, denominator 100, it's 150, it is 120. okay, this calculation only we should do. Okay, now we'll see what we'll get. So 150 divided by 120 125. Okay, this is called refractive index of liquid to glass. Okay, once you found this, then only the answer will be, you can do easily 150, 125. So 125 one time. Okay, here 5, 2 will be there, 0.0. Okay, so 250 as a 2 times. So refractive index of liquid to glass is going to be 1.2 no unit. Okay, now we'll start the problem. See the first equation, the focal length of air is equal to 1 refractive index of A to G minus 1, 1 divided by R1 minus 1 divided by R2. This is equation 1. 1 divided by 20 is equal to, this is 1.5 minus 1 into 1 divided by R1 minus 1 divided by R2. It is equation 1. Now I am going to teach you how to do with the equation 2. Equation 2, if you want, 1 divided by focal length of liquid is question mark. It is going to be refractive index of liquid to glass minus 1. 1 divided by R1 minus 1 divided by R2. Now 1 divided by focal length in liquid, we don't know. This is 1.2 minus 1. Okay, R1 minus 1 divided by R2. Equation 2. Both the ratio I am taken. Okay, equation 1 divided by equation 2. So that's called 1 divided by focal length in air divided by 1 divided by focal length in liquid. This is 20. Okay. So refractive index of A to G, 1.5 minus 1 divided by 1.2 minus 1. Okay, equation 1 and divided by 2. That's it. Very simple. R1 minus 1 divided by R2. 1 divided by R1 minus 1 divided by R2. Say common term you can cancel. So remaining as it is, denominator directly will come into the numerator. Focal length in liquid, focal length in air is equal to 0.5 divided by 0.2. So this will come here. So focal length in liquid is equal to 5 by 2. Just a 10 numerator, 10 denominator, multiple 5 by 2. Focal length in air. Focal length in air already we know 20. So 20 divided by 2, this get cancelled. Okay. So when it's getting cancelled, 10 will be there. So the answer will become as a 50 centimeter focal length. The focal length will be increased as a 5 centimeter. It's going to be positive. Still it will be behave as a convex nature only. Okay, thank you for watching my channel. If you like my channel, please subscribe. If you want more video, you can go and see my playlist. Thank you.